Alright, it's Miss Aarons here, and I just kind of wanted to go through the formative assessment with you because I did not get a chance to really go through it with you yesterday. So I want you to watch this video, obviously, before you take the new formative assessment. Let's start off with number 1. We have aqueous bismuth 3 nitrate. Reacts with aqueous sodium sulfide, yielding bismuth 3 sulfide, which is a solid, and sodium nitrate, which is aqueous. So where do we start? Well, let's start at the very, very beginning. Don't need that. Okay, I'm gonna write in, let's go with black. Okay, so we have aqueous bismuth 3 nitrate. Okay, so bismuth is gonna be Bi. I find that on the periodic table. This 3 is gonna show me its charge, so I know that's a +3 charge. And then we have nitrate, which is gonna be NO3, and that's gonna be Nick from the sentence that we used. And so it has one vowel, so it's going to be a -1 charge. We're going to add that to sodium sulfide. So sodium is Na. It's going to have a +1 charge. Sulfide, which is just going to be sulfur, and that's going to have a -2 charge, and that's going to produce bismuth sulfide. So Bi +3 and sulfur, the -2, plus sodium nitrate, so Na +1 charge plus NO3, which is a -1 charge. Okay, so when you're looking at this, these are all ionic compounds, so we know we have to do the crisscross method. So let's go ahead and do that. So we have BiNO3, and we have 3 of those now, plus Na2S, which is going to produce Bi2S3 plus NaNO3. And we can even add the states of matter in there. We know this is aqueous, so it's going to be AQ. This is also aqueous, AQ. This is a solid, and this is also aqueous. Now let's look at balancing. So when we're going to balance this, we're going to have to make sure that we have the same number of Bi's on both sides, same number of NO3s on the same side, same number of sodiums on this side, and same number of sulfurs on each side. So on this side we have Bi, we have 1 of those. NO3s, we have 3 of them. I know that from this number right here. Sodiums, I have 2, and sulfurs, I have 1. On this side, Bi's, I have 2, sulfurs, I have 3, sodiums, I have 1, and NO3s, I have 1. Okay, so let's start with the Bi's first. We have 2 on this side, but only 1 on this side. So I'm going to add the coefficient of 2. So that's going to come here, gives us 2 Bi's. And that's also going to give us 6 NO3s. We're going to multiply those. Next one, we have 2 sodiums on this side and only 1 over here, but we have 6 over here, so let's weigh off on that one. Let's do the sulfurs next. So for sulfurs, we have 3 on this side and only 1 over here, so let's go ahead and put a 3. So that's going to give us 6 sodiums, and then now we have 3 sulfurs. So this is the only one we have left to balance. So we have 6 sodiums over here, 6 nitrates over here, so let's put a 6 in front. Now we have 6 sodiums and 6 nitrates. Now that is all balanced. The type of reaction is going to be a double replacement. The reason it's a double replacement is we have 2 things getting replaced here. We have the NO3 that's getting replaced with the sulfur, and the sulfur is getting replaced with the NO3. So hopefully that clears things up a little bit. Now, if we look at the solid lead that is combined with FeSO4. So this is going to be a single replacement. If we have Pb, which would be lead, and we're adding that to iron sulfate, okay, we have this metal is going to try to replace this metal, so it's a single replacement. So you need to look at your activity series. When you look at your activity series, you can find lead, and if you find iron, iron is above lead on the activity series. So this one is below iron. It's below that one. So it can not replace it. It will not replace it. So there's no reaction. Okay, this next one actually wasn't even on your it won't let me do it. This one wasn't even on there. We actually took this one off because it's so hard. Let me color, pen. Okay. Okay, so I'll do the next one from the other one. So we have Cu and NO3 and silver. So Cu NO3 plus Ag. Okay, again, this is a metal, so it's going to replace the metal on this one, so it's trying to be a single replacement reaction, so you need your activity series. And we have silver that is below Cu, so this one is below Cu, so no reaction will occur. Next one. Okay, this is kind of crazy. Okay, it is an ether. This is still a hydrocarbon, and we're adding it to oxygen. So we're going to have CH3OCH3 plus oxygen, O2, is going to produce the same products every single time. It's going to be CO2 plus H2O every single time. So all you have to do is balance it. It's a combustion reaction. So the easiest way to do it is to go ahead and double this. So now we have 2 carbons. We have 6 plus 6 is 12 hydrogens. And we have 2 oxygens plus these 2, so that is actually 4. Let's look at this one. We have 1 carbon. We have 3 oxygens. And we have 2 hydrogens. So let's go ahead and try to make that happen. So let's put a 6 here. That's going to give us 12 hydrogens. It's going to give us 6, 7, 8 oxygens now. Let's try to get our 2 carbons. So let's put a 2 here. That's going to give us 2 carbons. 4 plus 6 is going to give us 10. Put a 5 here. And that should give us 10. I think I balanced that right. Sometimes it's hard to balance it. Believe me. Sometimes it can be very, very difficult to recount those atoms. So that's going to be 2. Well, that's going to be 12, so that's not right. So let's look at this again. Might be easier to look at this problem as this way too, because it's the same exact thing. Same exact thing as C2H6O plus O2. See how I just added those together? Is going to produce CO2 and H2O. Okay, so we know we need 2 there. So that's carbon's gonna have 2 now. That's 4. Oxygen's gonna be 5. Hydrogen's gonna be 2. This side we have carbon, that's 2. Hydrogen, that's 6. And oxygen, that's 3. So we need to put a 3 there. So that's going to give us 6 hydrogens. It's going to give us 3 plus 4 is 7. So if we would put 3 here That's going to give us 6 plus that 1 is going to be 7. There you go, and it's still a combustion reaction. Okay, the last one that I am going to do, I'm actually just going to erase this one here. So erase this all. The last one I'm going to do is the bottom one. So it's going to be H, oh, no, pen, black, okay, H, NO3 plus MNOH, and it's going to produce, that's what we're trying to figure out. Okay, so we have a metal and a metal, and a non-metal here, and a non-metal here. Remember, this 2 right here isn't going to go with it on the other side. This is just actually the charge of this because this is an ionic compound. So all we have to do is move this over here, and we're going to move that over there. So we have H, which is a +1 charge. We have OH, which is a -1 charge. So we're just going to wait to do the crisscross. Plus, we're going to do Mn, which is a +2 charge, and we have NO3, which is a -1 charge. Okay, now we can do the crisscross. So we have HOH plus Mn NO3. We're going to have 2 of those from the crisscross. Now we would just have to balance. We can keep this OH together when we're balancing too. So it should be HNO3 plus MnOH2 yields. So H we have 1, NO3 we have 1, Mn we have 1, OH we have 2, H we have 1, OH we have 1, Mn we have 1, NO3 we have 2. So let's put a 2 here. So that's going to give us 2 there and 2 there. Let's go ahead and put a 2 here. So that's going to give us 2 there and 2 there. So there we go. What type of reaction is that? Double replacement. Hopefully that helps a little bit. Watch this again before you redo your formative assessment. Have a great day.